So first thing I'm going to point out to you guys is the student math league test here. It is going to be on this Friday in CLA 116. It's from 12 to 1 o'clock. You got 1 hour to do your test. This is the fourth round. So you will have another round in spring. So if you are taking calculus or taking another math class, I would recommend you to take this again in spring because this is a whole America is doing this math test. So and the results will be posted. I think they will send me the result next week and I will start grading it. It's 20 multiple choice question. On top of the top 3 scorers cash prizes, the score that you earn in this student math test will be added to your third test as an extra credit. Okay, so it'll be added to your third test as an extra credit. So I would recommend you guys to come to this Friday and do it. You are allowed to use a graphing calculators for this test. So if you don't have a graphing calculators, you can borrow it from me. It's going to be it's going to be difficult. So I would recommend you to try it at least. You can at least do 1 or 2 questions in an hour if you can. Okay. Otherwise, if you can do more than 10 questions, then it's really good. Anyone have any questions with the math test here? Oh, yep. Anyone?
You said we can do the 10 problems on that that test that's this Friday, you said?
That's really good. If you can manage to, I mean, 10 and you get all 10 correct. Now the thing is,
No, yeah, because I was looking at the test from the last 2 years and I was just thinking like we don't know like 60% of what's on that exam. So
it's gonna be there's some trigonometric stuff in there, and some of them are probabilities that so it's challenging, so and logic, so it's not coming from my class. This is not from me. This test is not from my class, from this class. This test is for the whole American, whole 2-year college America taking it. So you have to, this is something that is out from this class, maybe a little like 30, that's what Kelvin said, 30 to 40% looks very similar. I mean, you know a little bit, but I would recommend you, yeah, it's tough. Even I can only do like, 7 questions in an hour. So it's not, I think, yeah, and someone in this college did it like 15 correct answers out of 20, like 1 semester. That's the only time I see, wow, that's good. So I would recommend you guys to practice this. I mean, if you want, do come and try it. Okay, and it's not hurting you. Actually, it's actually you gain something beside the headache you're gonna get. So yeah. So do practice. If you have any questions, you can talk to me. All right. So today we will continue with 6.5. So on Monday class, I teach you guys how to draw the sine, cosine, the secant, and the cosecant graph. So today we will concentrate on tangent and cotangent graph and how we graph it. And then we'll do some word problems on some other problems on these questions. So for this tangent graph, so this is 6.5, we're going to do some tangent graph here. So we're going to draw the basic tangent graph. Okay. So the same thing we did last time here in your sine and your cosine graph is we use x and y, and because our x in this case is theta, which is angles. So we will use back the same 5 numbers or 5 angles we use: the 0, the pi over 2, the pi, 3 pi over 2, and 2 pi. So these are the 5 theta that we use. And then for the y values, we look at the unit circles. So if you still remember your unit circles, this is a unit circles. So last time sine, we use the y value, cosine, we use the x value. So for the tangent, we will use the y over x. So you divide this up. So when you do the tangent 0 degrees, tangent 0 degrees in this case is 0. Okay, so tangent 0 degree in this case is 0. Okay, next we have is tangent pi over 2. So when you look at the pi over, this is special. When you look at tangent pi over 2, the tangent for 90 degrees is actually undefined, because when you take 1 over 0, you get undefined case in this case. So for the pi over 2, this is undefined. Okay. For pi, you get 0. Okay. For 3 pi over 2, you get undefined, again because the denominator is 0. And then for 2 pi, you get back 0. So for this tangent, you got 0, undefined, 0 for pi. For 3 pi over 2 is undefined, and 0. Okay. Now, if you look at this, when you have an undefined case in this case means you will have to draw me your vertical asymptote. Okay. So the undefined case we have here, you have to do the vertical asymptote. So if you draw your graph for tangent theta, where your x-axis here is theta and the y value is tangent. So you got 0, 0. And then you got pi over 2. At pi over 2, this at this value, it is undefined. At this angle, it is undefined. Okay. And then at pi, this will be at 0. And then at 3 pi over 2, this will be undefined. So undefined for me is, again, class, is going to be a vertical asymptote. And then at 2 pi, it will be at 0. So if you look at this graph, you only get all the zeros here. So again, you cannot graph this tangent graph using just these 5 points, because you only get this 0, 0, 0 here. You don't have any values. So what happens in this case is I will add additional points on this. I will use the over 4. I will use pi over 4. I will use 3 pi over 4. I will use 5 pi over 4 and 7 pi over 4. The reason why I'm using all the 4s is because if you refer back to your unit circle, if you look at the pi over 4, the 3 pi over 4, 5 pi, and 7 pi over 4, when you look at your tangent, your value in this case is either what? 1 or -1. So that means it's easy for us to graph this value instead of √3 or √3/3. You know, the number is a bit off. So as you know that in pi over 4, your value in this case is 1. And then in 3 pi over 4, the value in this case is -1. So what we have in this case is, so we got pi over 4, you got 1. 3 pi over 4, you end up with -1. And then if you go to 5 pi over 4, 5 pi over 4, because it's in quadrant 3, so tangent is +1 here. And then in 7 pi over 4, it's in quadrant 4, so tangent is going to be -1. So on 5 pi and 7 pi over 4, 1 is 1 and 1 is negative. So in this case, I will slot this as 5 pi over 4, which will get 1. And 7 pi over 4, which we will get -1. So I'm using this extra point so we can draw it up. So at pi over 4, so where is pi over 4 in this tangent? It is right in the middle between 0 and pi over 2. So this is pi over 4. Okay, and your value in this case is 1. Okay. Where is 3 pi over 4? 3 pi over 4 is between the pi over 2 and pi, which is right here. And the value in this case is -1, the one in purple. Where is 5 pi over 4? 5 pi over 4 is between the pi and 3 pi over 2. So this is quadrant 3. So this is 5 pi over 4. And the value in this case is also 1. And then 7 pi over 4 is between this 3 pi over 2 pi, and the value is negative 4. So now you notice that you will have these 3 points here. So we can draw the tangent graph. So your tangent graph will be something looks like a cubic graph. Okay, it looks like a cubic graph. This side will be also looks like a cubic graph. And then this one is also looks like a cubic graph. Okay. So this is your tangent graph. And if you look at your asymptote, your vertical asymptote in this case is going to be pi over 2, 3 pi over 2. And if I want to draw another one over here, this will be 5 pi over 2. So it's easy to see. And then if I want to go to this side, this will be negative pi over 2. And if I want to continue drawing my other asymptotes here, this will be negative 3 pi over 2. So these are my asymptotes for your tangent. And then your graph looks like a cubic graph. Okay. Now, so this is the tangent graph. I just draw it nicer so it looks like that. So we need to know what is your domain and range here. So the domain in this case is all real numbers, except x in this case cannot be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So we just use pi over 2 plus k pi or n pi. Either you use k pi, n pi, not really matter with me. And where k in this case is integer. Your range in this case, because this graph goes from negative to positive infinity. So your range in this case is all real numbers. Your y-intercept in this case is at 0, 0, which is this fellow. Your x-intercept, so if you watch carefully at x-intercept, it's going to be at 0, pi, 2 pi, 0, pi, 2 pi, 3 pi, so it's going to be k pi 0. So that means that your k in this case is integers, which is 0, 1, 2, 3, 4, 5, or negative 1, 2, 3, 5. This graph is an odd graph. It is an odd function, means that it is symmetry with respect to the origin. Okay, so this is the tangent graph. Okay. Now, usually, when you guys do your sine, cosine, secant, cosecant we did last time, the period that you found up here, you find on those is 2 pi, because every 2 pi is a new cycle. For tangent, it is special, is because the period for tangent here is only pi. Okay. How do we know the period is pi? Is because if you look at the one that close to the y-axis, it is repeat on the next one. And if you look at the vertical asymptote is between negative pi over 2 and pi over 2. That's the reason why that your period in this case is going to be just pi. Okay, and how do I find pi? Is because it's pi over 2 minus pi over 2. So you take the second asymptotes, subtract from the first asymptote. So that's why this is half plus half. That's why you got 1 pi. So the period for a tangent in this case is pi. Okay. Now, as you remember that when you have the amplitude and so on, you know, like what we did in sine and cosine. But for tangent do not have any amplitude. The reason why tangent doesn't have amplitude here is because it doesn't have a minimum and maximum point, because it goes to negative and positive infinity. So it doesn't have an amplitude, but your period in this case is pi over b. So remember last time the period for sine and cosine is 2 pi over b. So for this case, your period is only pi over b. Your phase shift is still c over b. Okay, so this is no, so the only change that you have seen in tangent is the amplitude. We don't have one for tangent. And for the period, instead of 2 pi over b that you guys use in sine and cosine, or secant or cosecant, we use only pi over b. And phase shift, same formula, c over b. So this is the tangent case in this case. Questions? All right, so so this is tangent. So now we're gonna do the cotangent piece here. So in order for you to find the cotangent piece, we're gonna use back the same points here. Okay. So we're gonna do the cotangent in this case. So again, we're gonna use the theta and the y, and then we're still gonna use the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. So it's the same same thing with sine and cosine. So now what you do with the unit circle here now is, instead of y over x, you have to do x over y. So if you look at the 0, if you take x divided by y, you got 1 divided by 0. So in this case, cotangent 0 is actually undefined. Okay, so for cotangent 0, this is undefined. Okay. When you look at cotangent pi over 2, it is x over y, so it's 0 over 1. So 0 over 1 is 0. So that is your cotangent pi over 2 is 0. And then you do the cotangent pi, it's going to be -1 over 0, x over y. And again, because it's over 0, at this case, this is undefined. And then at 3 pi over 2, which is down here, it is going to be 0. It will be 0 over -1, x over y. So in this case, it will give you 0. And 2 pi, which is the same thing as 0, this is undefined. Okay. And again, when you draw the cotangent graph, all the undefined case that you see here is your vertical asymptotes. Okay. So in this case, your vertical asymptote in this case will be 0. Okay, this is at 0, sorry. At pi, so at pi over 2, you will get 0. At pi, it's a vertical asymptote because it's undefined. At 3 pi over 2, you will get 0. And then at 2 pi, is undefined. So again, what you notice here is that you only got 2 dots here. We cannot draw a graph. So we have to do additional points. So we will use pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4. And the reason why we are using this again over 4 is because same thing with tangent. We're dividing. So they are the same value. So the x and y is the same value. So when you divide for cotangent pi over 4, you still get 1. For cotangent 3 pi over 4, when you divide this, you will still get -1. 5 pi over 4, when you divide these two, because of 2 negative, when you divide, it's still +1. And then at 7 pi over 4, when you divide these two, you get -1. So what happens to this case is the pi over 4, quadrant 1 and quadrant 3, you will get a +1. Quadrant 2 and quadrant 4, which is the 3 pi and 7 pi over 4, you will get a -1. So now we got 4 extra points here to plot. So pi over 4 is again right in the middle of the 0 and pi over 2. So you will get 1. And then 3 pi over 4 is in the middle between 0 and pi. So this is right. So every time when you do tangent and cotangent, you always do the middle, which is the 1 over 4. That will be easy for us to do, especially on a graph paper. And then 5 pi over 4 is right in the middle between pi and 3 pi. You will get 1. And then for the last one, 7 pi over 4, which is in the middle, 3 pi over 2 and 2 pi, you will get -1. So what do you notice here is you got these 3 dots, 1, 2, 3, and 1, 2, 3. So your cotangent graph is actually is kind of like the opposite or reflections on the y-axis of the tangent graph. So it's kind of go the other way of the tangent way. So this is a cotangent graph. Okay, so tangent graph looks something like this. Cotangent graph go the other direction. Okay, so this is your cotangent graph. How do we do your domain and range in this case? So your domain in this case is going to be all real numbers. X in this case cannot be k pi. The reason why is because if you look at all your vertical asymptote, it is 0, pi, 2 pi, 3 pi, 4 pi, -pi, -2 pi, and so on. So that's why your domain in this case is all real numbers. X cannot be k pi. Your range in this case is all real numbers, since it goes from negative to positive infinity. Your y-intercept in this case is undefined. The reason why, or DNE, the reason why that your y-intercept is DNE is because this graph does not cross on the y-intercept, because that's your vertical asymptote. Your x-intercept, if you look at your x-intercept, is going to be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So it will be pi over 2 plus k pi. Okay, so your x-intercept is pi over 2, 3 pi, 5 pi over 2, and then if you go negative pi over 2, negative 3 pi over 2. So it's pi over 2 plus k pi. And this is also is an odd function, means that it is symmetry with respect to the origin. Okay. If you talk about the period for this cotangent graph is still pi. Is because period is measured between in this case 2 consecutive vertical asymptotes. So since it goes from 0 to pi to 2 pi, so that means your period in this case is pi. Okay. As usual, your cotangent does not have amplitude. Okay, cotangent does not have any amplitude because it doesn't have a min and max, equals infinity. Your period in this case is going to be pi over b, and your phase shift in this case is c over b. So it's so you find out that the amplitude, the period, the phase shift is the same as tangent. Okay. Now when you guys draw a cotangent graph or a tangent graph, you need to figure out what we call as your vertical asymptote. So for this case, you start with bx minus c equals to 0. Remember last time on Monday, we take bx minus c is where you start. So in this case, we start at 0 because your vertical asymptote starts at 0. And it ends at bx minus c equals to pi. Why this ends at pi? Remember sine and cosine, it ends at 2 pi. Is because in one cycle, your cotangent starts at 0. and it ends at pi. Okay, so you have to solve for x here. So if you solve for x in this case, you will get yourself your vertical asymptote. Okay, so again, for cotangent, we use bx minus c equals to 0 and bx minus c equals to pi for the starting point and the ending point. Now, if you do not want to use 0 and pi, you can also use pi and 2 pi. So every time when you want to pick the how you figure out your vertical asymptotes, you have to take the 2 consecutive vertical asymptote. So either you want to take 0 or pi, or you take pi or 2 pi, or you take 2 pi, 3 pi. But I would recommend you to do 0 pi because when you solve for it, it's easy for us to solve, especially with the 0 case. Okay. So this is the cotangent graph in order for us to do. And you do not need to use the 5 coordinate points. Remember last time when you do the sine and cosine, you have to do the 5 coordinates point. You know the so you do not need to do this. So you just need to watch out for your vertical asymptotes in this case. Okay, so I'm going to go back to the tangent one because the tangent one I forgot to give you the vertical asymptote. So for the tangent piece, which is this one, so your vertical asymptote in this case, the starting point that you have, which is bx minus c, we don't use 0 and pi because if you look at the tangent graph, your vertical asymptote doesn't have 0 and pi. So actually we will use this 2, the pi, negative pi over 2. That's where you start. And we end with the positive pi over 2. So bx minus c equals to pi over 2. And you will solve for x here to start your starting point. And you solve for x here to have your ending point. So we always try our best to pick the vertical asymptote that is very close to the y-axis. Okay, so you can still use pi over 2 and 3 pi over 2, but I will recommend you to use the one that close to the y-axis because when you do some translation or transformations, it's easy for us to figure it out. Okay, and again for tangent and cotangent, you do not need to worry about doing the 5 coordinates points. So this is the details of tangent and cotangent graph. So we're going to do some examples here. Okay. So we will look at the example for tangent and cotangent. So these are the few examples we'll do. So the first example we are doing here is y equals to -2 tangent of 3x. So it's the same type of format is where I will ask you for A, B, C, D. And if I want you to put parentheses on this question 1, where should we put the parentheses in here?
Around the 3x.
Just on the 3x. So just want you, the reason why I want you guys to know this is because this is your bx minus c. Remember when we need to do that? So inside your parentheses is always a bx minus c. So make sure if they don't have a parenthesis, means it's just right next to the tangent or cotangent or sine. So, all right, so can someone tell me what is your A, B, C, D in this case? A in this case is
A is 2.
-2. We have a negative.
3.
3 is B. And we
0.
don't have, 0. You can use 0, When I put cross means it's 0, so we don't need to use those. Okay. So we do not need to find amplitude here is because tangent and cotangent, we don't need to find amplitude. But the period is actually pi over B. And the phase shift formula is C over B. So in this case, your period in this case is pi over 3 because our B in this case is 3. Phase shift in this case is 0, or we don't have one. It's because our C is 0. So you do not need to do one. Okay. Now, last time, if you remember sine and cosine we did on Monday, we have to do that 5 coordinates. Remember that? So you do not need to do that. Okay. So what do you need to do when you talk about tangent and cotangent is to figure out your vertical asymptote. So for vertical asymptote, the starting point for this tangent is you take the bx minus c, which is 3x, and you equal this to negative pi over 2. And the ending of the vertical asymptote is you also take 3x minus bx minus c, in this case is 3x, and you equals to pi over 2. And the reason why we are using this is because originally the tangent vertical asymptote is at negative pi over 2 and pi over 2. So what you need to do here is to solve for x. So I divide everything here by 3. So what is your vertical asymptote in this case? Anyone?
Negative pi over 6.
So you start with negative pi over 6 and you end with what?
Pi over 6.
Pi over 6. So this means that at negative pi over 6 is where you start at your vertical asymptotes. And pi over 6 is where you end your vertical asymptotes. And don't forget, I need 2 cycles. So the next one that we have here. So how do we know what is your next vertical asymptotes? Is looking at you just need to add your period. Okay, because to get from here to here, you add the period. So the period that you found in early on here is pi over 3. So what do you do here is you take pi over 6 plus pi over 3. Does anyone know what is pi 6 plus pi over 3? This is actually is 1/2, pi half. Okay. So this, I mean, if you want to figure out what is the next one, you keep on adding pi over 3 because our period in this case is pi over 3. Now, if you remember, your tangent graph looks something like this. Okay, that means right in the middle of these 2 asymptotes, it at 0. So right in the middle of this, which is at 0, it will be at 0. Right in the middle of this, it will be at 0. Okay, and if you want to figure out what is the middle of this, what value is this one? This is 0. You add this and divide it by 2. So what is pi over 6 plus pi over 2 divided by 2? Because that is like a midpoint. This one will give us, this is times 3, 4 pi over 6 times 1/2. So this is pi over 3. This is pi over 3. Okay. And then remember that if you do the middle between these 2, this is at 1. Okay. So the middle between these 2, this is going to be at 1. And the middle between these 2, it will be at negative 1. Okay, same thing, the middle of these 2 will become negative 1. The middle between these 2 is at 1. So you notice that this is, if I want to draw this red line, this is what your tangent graph looks like. However, this tangent graph that I draw, the red line, is wrong. So do not draw the tangent line here. The one that, the reason why I say it's wrong is because of one important thing, your A. Okay, this A changes your Y value. Remember when you do your sine and cosine graph, your Y value is changed depends on your A and your D. Okay, this change your Y value. The good news is the D is 0, so we don't need to move up and down. But what happens to the A is we need to multiply this by -2. So if you look at this point is at -1. So you have to multiply this at -2. And this -2 is because of the A. So this -1 will move to 2. Let me repeat. Because your A is -2, it will affect your Y value. And for your Y value, we have a -1 here, and you have to multiply by -2. So which is your A, that will give you 2. Now we also have 0, but 0 multiplied by any number, you still get back 0. So this 0 remains the same. And then we have 1. So 1 times -2, you will move this down to -2. So the correct graph for this tangent looks something like this. So it's no longer at -1, 0, 1. It's gonna, for the Y value, it's gonna be at 2, 0, -2 because of your A. So this graph, the next cycle will look something like this too. So this is the graph for this question 1. So I just want to point out again, watch out for your A and your D, because that will change the Y values that you have here. Questions?
So if your A was +2, it would look the other way, right?
It will be exactly like
Regular
this.
way, the red,
Will
the
be
one
the,
you drew in the red the first time.
Yep. It'll be the same thing as this. So when, if your A is a +2, so now this fellow is no longer at 1. This fellow will be at where? 2 and -2. So your graph is a little bit skinnier. Okay. So don't forget, this A is what we call as a vertical stretch. So if your A is a big number like 2, 3, 4, your graph is getting skinnier. Okay. If your A is like a fraction, like 1/2, between 0 and 1, like 1/2, 1/3, then your graph is getting a bit fatter. Okay. So that's the vertical stretch and shrink that you learn in your in the beginning of the class. So that's why that A plays an important role for changing the value for the Y. Questions? Difficult? It's less work compared to your sine, cosine, or secant or cosecant, but it is still, you know, a lot of work actually, but it is lesser work than the one that you did. Okay. We're going to talk about the cotangent graph here. So this is given the parenthesis, which is good. So y equals to 2 cotangent x plus pi over 2. So don't forget, this is our bx minus c here. You're the one inside the parenthesis. What is your ABC in this case? And D. We don't have an amplitude here because it's cotangent, but we have a period and a phase shift, which is pi over b and c over b. Anyone? A, B, C, D? Come on.
A is 2 and B is 1. And C is pi over 2.
Not pi over 2.
Negative pi over 2.
Thank you. That is correct. So be careful. Your sign switch for C is plus become minus. How about D?
There isn't.
There's no one. Yep. So I just put 0. I can exit out. Okay. We don't do any amplitude because cotangent doesn't have one. So your period in this case is pi over 1 because your B is 1 here. So it becomes pi. Your phase shift in this case is C over B. This will be negative pi over 2 over 1 because your B is 1. So this is your periods and this is your phase shift. So that means that if your period is pi, means your vertical asymptote is still the same, no change. Okay, but your phase shift means you move your vertical asymptote to your left because negative means you move it to your left by pi over 2. Okay, so how do you find your vertical asymptote in this case? Is you take the starting and the ending point. The starting point, you take the bx minus c, which is x plus pi over 2. And because this is a cotangent, so cotangent, we use starting point at 0 and it ends at pi, because the original cotangent graph, if you remember 15 minutes ago, is we start at 0 and then the next one is pi and then the next one is 2 pi. That is for cotangent. So be careful with tangent and cotangent. Cotangent is this, tangent is what? Negative pi over 2 and pi over 2. So be careful with those two values we use. And we will solve for x here. So can someone solve for x for me here?
For the first one, x equals negative pi over 2.
Mm-hmm.
And the second one,
One half.
1/2, yes. So it's $1 minus 50 cents. So we got 50 cents. Yes. So your vertical asymptote in this case will be at pi over 2, negative pi over 2. This is where you start. And it will end at pi over 2. And if you want to figure out what is the next vertical asymptote that we have, you just need to add your period. Okay, so if you want to figure out what is the next vertical asymptote, you just need to add your period. So what is your period in this case? Your period in this case is pi. So what is pi over 2 plus pi? 50 cents plus $1. You get. This will be 3 pi over 2. And don't forget, your cotangent graph looks something like this originally. So right in the middle between this, it is at 0. And right in the middle between this, it is also at 0. And this one, the middle is pi, because this is 1/2. This is 1 and 3 half. So 1.5, 1.5, and so on. And if you look at half of this, it used to be at 1. And half of this, it is at negative 1. That's why you got this little. And then half of this fellow is at 1. Then half of the other one is at negative 1. So this is your cotangent graph without the change of your y values. Okay. So what you need to do with your y value in this case, class?
Multiply by 2.
Multiply by 2. Yep. So because we don't have a d, so all this needs to be times 2. So this used to be at 1. Now it will be at 2. This is 0. So multiply by 2 is still 0. This used to be at -1. So when you multiply by 2, it's -2. So again, your graph will getting a little bit narrower compared to the original cotangent graph. The reason why is because of that 2, that the a is 2, that pull it. So your graph will be this. Okay. So make sure just make sure you draw a little bit narrow graph compared to the original graph. Is because your a is 2. I multiply by 2. Anyone have any questions for me with this kind of tangent and cotangent graph? Difficult? Okay. I do strongly you guys to practice this. There are 2 types of questions come up in your test 3. One is a tangent cotangent graph, which is something like we just did here, and one is going to be a secant or cosecant graph, which we did on Monday. So again, when you do the secant and cosecant, you need to draw the reciprocal first, which is the sine or cosine, and then you do the vertical and the horizontal asymptote, and then you do the up down up down up down. Okay, that make sure you guys practice. I will definitely give you some review so you can practice about it. Anyone have any questions with this graphic before we start with the new section on 6.6, which is the inverse function? Right. So we're going to talk 6.6. What is the inverse trigonometric function? So so when we talk about inverse function, we did this before in early, like I think the first or second week of class. In order for us to have an inverse function, it has to be 1 to 1. What is the meaning when I say 1 to 1? It has to pass the horizontal line test. Okay. For example, is x squared. Okay, if you have a function of x squared here, if you draw me a function, the graph of x squared is a parabola. Okay, and we know that this function x squared, this is not 1-on-1. Okay, this fellow is not 1-on-1. The reason why this is not 1-on-1 is because when you draw me the horizontal line, it crosses at 2 points. In order for you to pass it, you need to cross at 1 point. So what we did in back in that time is we do what we call as domain restriction. Okay, so what is domain restriction means is I cut the domain. So I will just erase or take just part of this graph. Then if I just take part of that graph, then what happened is that this fellow is 1 to 1. Okay, so that means we only take x is greater than equal to 0. Then this fellow has it is 1 to 1, so it has an inverse function. So this is what you guys learned back in like 2.7 or 2.6, something like that. So this is for normal polynomial equations here, functions here. But now we're gonna do sine and cosine. So I'm gonna bring up my sine wave here so you guys can see. 6. So in a sine wave that we did before here, so remember this is a sine wave that we have, right? So sine wave, if you talk about one-on-one, this big line, it is not going to be one-on-one because if you draw the vertical line, horizontal line test, it fails. It intercepts a lot of points. Okay, so this is not one-on-one at all. So what do I do on this horizontal, on this sine wave is I will do what we call as a domain restriction. So that means that I will erase this sine wave so that it will pass one-to-one. And the domain restriction that I will pick is from here to here. That means I will pick from negative pi over 2 to pi over 2. So what do I do with the rest of my graph is I erase it off to that point, sorry. And then I erase the rest of it. So what you got here, it looks like an F. Okay. So when you do this, we will get what we call as a one-to-one functions now. If you restrict the domain into here. So if I restrict the domain from negative pi over 2 to pi over 2, then this is one-to-one. You guys got what I'm trying to say here?
So where would the domain begin if it's
It will be
restricted?
from negative pi over 2 till positive pi over 2. So instead of the whole sine wave, I just restrict to this. So I'm gonna go back to my one. So I'll show it to you. So what happened is that for the sine wave looks something like this: a hill and a mountain, a hill and a valley, and this is 1 and negative 1. So what do I do in this case? This is 0, this is pi over 2, this is pi, 3 pi over 2, and this is negative pi over 2. So what do I do is I restrict this from pi over 2 to pi. Negative pi over 2 to pi over 2. So if I domain restrict this fellow, that means I do not want him. I just restrict from here to here. You notice that you only get one line. So with that case, if you draw me a horizontal line, it is one-to-one. Okay. So for the sine wave, I will restrict the domain from negative pi over 2 to pi over 2, including. And then what happens in this case is your range will be negative 1, 1. Okay, because your range is still from negative 1 to 1. So this, once you have restrict your domain into here, then this sine function that you have originally will have an inverse function. And that inverse function is called the arc sine of it. So you can write down as sine minus 1x, or you can use the word arc sine of x. Choose parentheses. Okay. And if you remember, for our back into our inverse function, the range, the domain of the function is the same as the range of the inverse function. And the range of the function is the same as the domain of the inverse function. So they are switched around. So this is the same case. So if you have the arc sine of this, then the domain for this arc sine is from -1 to 1, which is the range of him. And the range of this inverse function is going to be from -pi/2 to pi/2. So it's this one. So that means your inverse function is being switched around. Okay. So this is what is written down on my notes here. So so in order for a sine wave to have an inverse function, you have to restrict the domain from -pi/2 to pi/2. Then you figure out that this has an inverse function, and the inverse function for the sine is called the arcsine, or sine -1x. So if you look at your calculator has that the sine and the cosine and the tangent, and when you look on top, you see the -1 on it. This is the inverse trigonometric functions. Okay, this is not cosecant, secant, and cotangent. So do not. So this is a note. Note that the inverse function for sine is not cosecant x. Okay, it's not cosecant x. Okay. A lot of people think that the sine -1 in your calculator is cosecant because it's 1 over it. No, it's not the same. Okay, so so this is what we do with sine. So we're gonna do the same thing for the cosine and tangent. So in this case, we only concentrate on 3: sine, and tangent. So so sine, we restrict it to from -pi/2 to pi/2. What happens to cosine in this case? So for cosine, we also need domain restriction on this case. So if you remember, cosine is the whole valley, and again, it does not pass the horizontal line test. So what do I do here is I will restrict the domain, and the domain restriction that I will use here is from 0 to pi. So if you look at 0 to pi, you just only get this little, like a little slash here. And this actually passes the horizontal line test because it is 1-to-1. So it will have what we call as a inverse function. So for this case, this is for sine. So for the cosine functions, we will use, this is the whole valley. We will restrict the domain from 0 to pi, which is this one. And if you restrict the domain from 0 to pi, and you erase, anything that is after that, then this graph will pass the horizontal line test. Means it will have a 1-to-1. So that means this fellow will have an inverse function, and the inverse function in this case is the cosine -1x, or we sometimes use the word arc cosine. And if you look at this cosine graph, your domain in this case is 0 to pi. Your range in this case is -1 to 1. So what happens is when you switch around, then your domain and range for the inverse function is switched around. So in this case, it will be -1 to 1, and the range is 0 to pi. Now this is all brackets. Brackets means it includes the value, the -1, 1, pi/2, -pi/2. So this is the cosine. So it's also written down in my notes, so you can see that. So cosine in this case, we use 0 to pi. It's -1 to 1, we restrict the domain. And now we do the same thing for tangent. So tangent graph is just the one that we just do today. So this is a tangent graph. And again, tangent graph does not pass your horizontal line test because it has a lot of intercept. So it's not one-to-one. So what do? Is we do the domain restriction, and we will pick just the first and the second vertical asymptote. So we'll restrict this from pi over 2 to negative pi over 2. So that will, if you restrict this, then it will pass the horizontal line test. So it will be 1-on-1 in this case. Okay. So what happens to your tangent? So this is a tangent. So tangent graph, we will restrict the domain from negative pi over 2 to pi over 2. And this is a tangent graph. And if you just do one cycle or one period for the tangent, then this will have a 1-to-1, or it has an inverse function. And that inverse function is the arctangent of it. So it's either tangent minus 1 or the word arctangent. However, if you look at this, your domain in this case is also negative pi over 2 and pi over 2. But since it has the vertical asymptote, you cannot include it. So you have to use parentheses. So that's the difference between sine and tangent. Sine, you use bracket. Tangent, we use parentheses because of the vertical asymptote. The range for this is still all real numbers because it goes from negative to positive infinity. And what happens to the inverse function? You flip it. Your domain in this case will be all real numbers. Your range in this case will be from negative pi over 2 to pi over 2, not including it because of your asymptotes. So that's why it is written down on your also notes here. So so please, there's a typo here. There's no equal sign yet. So take out the equal sign. So this is just so for tangent, for arctangent, do not include the equal sign. Okay, so take out the equal sign. So please erase those the equal sign here. Okay, so it's just only less than or greater than, less than in this case. Okay, so how do we find this kind of arctangent here? Is you need to be careful. Is because if you look at your range here, this negative pi over 2 to pi over 2, this is actually, if you look at your unit circle, negative from negative pi over to pi over 2 is here. This is negative pi over 2 to pi over 2. So that means this only involved with quadrant 1 and quadrant 4. So if you have a range that says from negative pi over 2 to pi over 2, for the unit circle, we don't use quadrant 2 and quadrant 3. We only use quadrant 1 and quadrant 4. Moreover, this quadrant 4, you go clockwise, means it's negative. Okay, because our range here is from negative pi over 2 to 0 and then to pi over 2. So that means this side is negative, this side is positive. But for your cosine is special because cosine, your range here is not from negative pi over 2 to pi, it's from 0 to pi. So that means that it will only have quadrant 1 and quadrant 2 for the inverse of cosine, and we don't use quadrant 3 and quadrant 4. So to teach you what do I mean here is we can do some examples now. We can use a unit circle. So for example is, what is arcsine of 0? Okay, so I show it to you what we do here. So so the first one is asking for what is the arcsine of 0. So in order for us to figure this one out, this is actually your value. So that means you have to find what is the y value. The reason why we find y value here is because sine is y value. You have to figure out what angle is this belongs to. Okay, so using the unit circle that you have here, so sine only work from quadrant 4 and quadrant 1. So from here to here, so you have to look at all your y values. So what y value here gives us 0? This is the only y value give us 0. So your answer in this case will be 0. So your answer in this case will be 0. Okay. Let me give you another one. What is the arc sine of root 2 over 2? So again, we are looking at the y value. So if you look at the unit circle, again, this is from quadrant 4 till quadrant 1. Which quadrant 4 here give us root 2 over 2? And our answer in this case is pi over 4. And if I change this to negative root 2 over 2. So if you look at here, so again, we are looking for quadrant 4 or 1. Which one of this quadrant, which one of this y value give us negative root 2 over 2? So for negative root 2 over 2 is this, which is 7 pi over 4. But if you give me 7 pi over 4, this is wrong. The reason why it's wrong is because the range of your sine is from negative pi over 2 to pi over 2. 7 pi over 4 is not in this range. So what do? Is you take the unit circle here. Instead of going counterclockwise, you go clockwise. So from 0 to 7 pi over 4, this is actually negative pi over 4. So in other words, if you see a negative inside this value here, you can, for arc sine, you can actually take the negative out. And the reason why you can do that is because sine is an odd function. So you can take the negative out. What happens if I do the arctangent? So what is arctangent of square root of 3? So again, for arctangent, you don't use the y value here. Tangent, in this case, you have to use the y over x, because tangent is y over x. So if you look at your unit circle, which y over x value from again, it's the same quadrant 4 and quadrant 1. Which one of these give us square root of 3? Yep, square root of 3. Anyone?
It's 4 pi over 3.
No, this is not in the quadrant. Again, it must be in quadrant 4 and quadrant 1. So you're going to do half of this circle.
Pi over 3.
Pi over 3. So in this case, this will become pi over 3. Okay. What happens if I ask you to do the arctangent of negative root 3 over 3? Anyone? Arctangent of negative square root of 3 over 3. Again, for arctangent, you look for 4 and 1. Half of the circle. Anyone?
11 pi over 6.
11 pi over 6, that is correct. However, 11 pi over 6 is wrong, because if you look at your tangent again, your tangent is only between negative pi half and pi half. 11 pi over 6 is already out of this range. Okay, so we need to figure out how we figure out this is instead of doing counterclockwise, we do clockwise. So can someone tell me what is clockwise if you go from 0 to 11 pi over 6? Which is the same as what?
Pi over
Negative
6.
pi over 6. Yep, so this is the same as negative pi over 6. Okay, so what I want to point out to you is for sine, inverse sine and inverse tangent, if you see a negative value inside, then your answer is what? Negative. Because this is odd function. So odd function means if you have a negative, your answer will be negative. If your answer is positive, then your value is positive, then your answer is also positive. Okay, now this is for sine and tangent, arcsine, arctangent. But what happens if you do the arc cosine? Okay. So again, for cosine, we don't look at the y value, you look at the x value. Now, this is special because this, I want you to look at quadrant 1 and quadrant 4, right? But for the arc cosine, you look at quadrant 1 and quadrant 2 because of the domain restriction. So when you talk about cosine, you look at 1 till 2. So that means from 0 to pi. This is why the range for him for the arc cosine is from 0 to pi. So can someone tell me by looking at the x value? I think I asked for 1/2, right? So what is the x value is 1/2 in this case? If you look at 1 and 2. So the x
Is it
value
pi over 3?
is pi over 3. Okay, so this will be pi over 3. And what happens if I ask for arc cosine of negative 1/2? So this case, again, you're looking for 0 to pi. Again, cosine, inverse cosine is always from here to here. So can you tell me which one of these value will give us negative 1/2 x values? What angle?
Pi over 3.
It'll be 2 pi over 3. So this you do not need to convert back to, you know, so the answer is 2 pi over 3 is because if you look at the range of him, the range of cosine, arc cosine is from 0 to pi, and 2 pi over 3 is between 0 and pi. Okay. What do I have here? We do that. We'll do that already. Give you another example. What is arc cosine of negative 1? Anyone? What is arc cosine of negative 1? Again, it has to be from 0 to pi.
Negative pi over 2?
No, I want 1. I want 1. I want negative 1. Sorry, I want negative 1. Sorry, that's the answer. Arc cosine of negative 1. This is 0. Forget. So which x value give us negative 1? Your answer in this case will be pi. So this is pi. You guys all right? Tough? I also take attendance, so can you guys take put present in the chat room? I'll give you. So be careful, class. This is something I will ask you in also in your test. So arc tangent, arc sine, quadrant 1, quadrant 4. Quadrant 4 has to be negative. For arc cosine, it is 1 and 2. Quadrant 1 and 2. Quadrant 2 is negative. That's because we know quadrant 1 is always positive. So so let me give you another one. So you guys try to do it yourself. You guys have unit circle, right? So I'm not going to show you the unit circle. You figure out yourself. I want you guys to figure out what is arctangent that is -1. So go ahead, figure this one out. The arc cosine of 3/2 and arc sine of -1. So go ahead, try to do this 3 question because I will ask this in your test 3, and a lot of students doesn't know how to use the unit circle to do this. So arctangent of -1, arc cosine of 3/2, and arc sine is -1/2. Without using a calculator. So otherwise you'll defeat the purpose of. You can use your unit circle, but not your calculator. Anyone? Anyone know what to do with this?
Is it for
9.
arctan of -1? Is it 7 pi over 4?
That is wrong. Close is wrong. And don't forget, what do I tell you along for sine and cos, sine and arctangent? If they are negative, you have to take the negative out. So can someone help? What happens if your answer is 7 pi over 4? That's wrong. Anyone?
Would it be -pi over 4?
Yep, this will be -pi over 4. I agree that is correct. Okay. So don't forget, you need a negative answer when it is in quadrant 4. So 7 pi over 4 is a positive. So in order for us to get that, you just need to subtract 2 pi. That's how you get that. Or if you're in the unit circle, you go the other way. Right, how about number 10? Arc cosine of √3/2. No, this is not, this is defined. For number 10, this is not undefined. This is defined. You have a number here. This is arc cosine of 3/2.
Is it pi over 6?
Yep. And what is arc sine of -1/2?
-5 pi over 6?
No, -5 pi over 6 is this way.
-pi over 6.
This is -pi over 6. Yep. So I just want to point out, class, for tangent, arctangent, and arcsine, you can take the negative out. So this is actually the negative of arcsine of 1/2. So this negative will take it out. Same thing with the negative. And if you look at the unit circle, you just look at 1/2. And 1/2 is this, which is pi over 6. So this will become negative pi over 6. Okay. So sine and arcsine and arctangent, you can do that because they are odd. Okay. So be careful with the negative piece here. Okay. Watch out. Okay. As I mentioned early on, if the for arcsine and arctangent, if the value you see is negative, your answer has to be negative. So that's why if your value for arcsine and arctangent are negative, your angle has to be negative too. Very important. Okay. Now, if you do not know if you are in the right track, you can always reverse back. So what I mean by reverse back is you move this back. So when you move it back, this will become 1/2 of cosine of pi over 3. So what happened is that, what is the meaning of arc cosine or arcsine or arctangent is if you move the cos to the other side equation, that will become arc cosine. But if you move arc cosine back into there, you will get cosine. So you can always check that, is it cosine pi over 3 is 1/2. So if you look at a unit circle, cosine pi over 3 in this case is 1/2. So that is correct. So so make sure you guys know you can always do that, move it backwards, so that your arc cosine will become normal cosine that you guys familiar with. We're going to do a little bit more. So about your notes here. This one, I think you can use your calculator, just punch it correctly. And usually they want this in radian. I just want to point out to you, we are using radian here. So so when you do your calculator, make sure this is in radian form. Okay. Question number 7, this is also easy, is use the inverse trigonometric function to write theta. So this is theta. X plus 1 is here. And then 10 is here. So 10 is here, X plus 1 is here. So if you have this kind of questions, then you have to use back your SOHCAHTOA. So can someone tell me what is, this is your hypotenuse. Then what is this 2 is? What is X plus 1? Is that your opposite or your adjacent?
Opposite.
Yep, and this is your adjacent. So can someone tell me which trigonometric sine, cosine, tangent that give us using opposite and adjacent?
Tan.
So tangent theta in this case is equals to what?
X plus 1 over 10.
Over 10. Okay. So this question wants us to write theta. So how do we just want to get theta by itself? We move the tangent over. And do you know what happens when you move your tangent over? This tangent will become what? It becomes the arctangent. So your answer in this case is, the theta in this case is arctangent of x plus 1 over 10. And I do recommend you guys to put parentheses on after finish doing your arctant or arc cosine or arcsine, because your online homework will mark you wrong if you don't put a parenthesis on it. Okay. Now, this is easy. So every time when you guys want to solve, if you have a tan or sine or cosine, you can always move it to the other side. And when you move it to the other side, it becomes the arc of it. Okay. And yep, so we're going to do one more, number 10. So, and then we'll come back on Monday to finish the rest. Sine of arc tangent of 3/4. Okay. Now, how do we do this kind of questions is you have to draw me the right triangles. So what do I mean by drawing the right triangle in this case is we will let this whole thing become theta. So what do we do here is, instead of last time moving the tan over to become the inverse, So we do the opposite. We move this back over here. So the arc will become a regular tangent. So this is a tangent theta equals to 3/4. So with this, you can draw me a right triangle. You can do your SOHCAHTOA. So can you tell me, using this tangent theta equals to 3/4, what is this? 3 is your
Opposite,
and 4 is your
Jason.
adjacent. So we got 3 on the opposite, 4 in your adjacent. Can anyone tell me what is your hypotenuse here? You guys should know 3, 4, and
5.
21.
5, right? Okay. Otherwise, you have to use Pythagorean to figure out. So now what you do here is, this question is asking you to find what is sine theta, because this whole thing is replaced by sine theta. So looking at this triangle, this right angle triangle, can you tell me what is sine theta? Sine theta is what over what? Opposites over what? Hypotenuse, right? So what is sine theta in this case? Three over 5. So the answer for question 10, what is the sine of an arctangent of 3/4? Then my answer in this case is 3 over 5. Okay. So you do need to use your SOHCAHTOA here to figure out the two one, and then the last one you have to figure it yourself, either using the triplets or using the quadratic formula. And then you use back SOHCAHTOA to figure out your sine, cosine, whatever they ask you. So this is question number 10. So if you want, you can try to do question number 11. We'll just do 11. So it's just, so question number 11, we got cosecant of the arctangent -5/12. So again, we're gonna let this fellow become theta. So we always let the one in the parentheses become theta. So again, we move the arctangent over there. So this is tangent theta equals to -5/12. Now, because this theta that we have here is a positive, that's why your triangle is in quadrant 1. But since this theta, this value that you have here is a negative, this is going to be in quadrant 4. Because tangent is positive in quadrant 1. For this case, we don't use quadrant 2, we use quadrant 4 due to the domain restriction. So your quadrant 4 will look something like this. This is your theta. -5 is the one that is opposite. And 12 is your adjacent. So can someone tell me what is your hypotenuse in this case? 5, 12, anyone?
13.
13, yep. So now this will become cosecant theta. Can someone tell me cosecant is what over what? Hypotenuse over by opposite, right? So your answer in this case is yep, you're correct, -13 over 5. You guys all right? Tough? Not too bad. The most difficult part that I'm thinking about for this kind of questions is just be careful the quadrant, because a lot of students make mistakes, especially the negative one. The positive one, you guys are good because it's always in quadrant 1. The negative one is the one that throws people around. So make sure you practice a little bit, especially the negative one, because that is the one that a lot of students make mistakes in the test. Right, so I'm gonna end this Zoom here. So so don't forget you have 2 homework due tonight, which will be 6.4 and 6.5. And I will recommend you start 6.6 this week because I will see you guys on Monday. So don't wait. You got 2 homework due next Wednesday too, 6.6 and 7.1. So 6.6 we are almost done with it. Just get a few more questions left, and then we'll start 7.1, which is a little bit tough for that. So once we hit chapter 7, the materials are tough. Okay. So if anyone have any questions, please stay back and ask me. Otherwise, you may go. And if no questions,